Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 9th, 2026, just 2 days ago. It introduces a unified family of graphical user interface agents that sets a new standard for digital automation, achieving nearly 78% accuracy on the Android World benchmark. The paper is titled UI-Venus-1.5 Technical Report. And as we'll see later, the training methodology here offers some really compelling insights into building robust agents for real-world applications. And for those interested in the implementation, the authors have shared their code on GitHub. Hugging Face hosts the 2 billion, 8 billion, and 30 billion parameter models. You will also find VLLM code examples to help you deploy these agents right away. To see how these models stack up against the competition, Figure 1 presents a comprehensive performance overview. The top section uses radar charts to compare grounding capabilities, which essentially measure how well the model identifies specific screen elements. Across the 2 billion, 8 billion, and 30 billion parameter scales, the UI-Venus models, shown in dark blue, consistently outperform competitors like Qwen3VL and GUI Owl. Moving to the bottom section for navigation tasks, the bar charts confirm this dominance. On the Android World benchmark specifically, the 30 billion parameter variant achieves a state-of-the-art 77.6% success rate, clearly surpassing previous leaders. Well, Figure 2 visualizes exactly how this system operates as an end-to-end agent. The top panel outlines the workflow, where the model takes a user command, perceives the screen through pure vision, and drives mobile or web interfaces using tools like ADB. On the right, the authors highlight real-world utility, displaying icons for major apps like WeChat and TikTok. Beneath this, the bottom section presents concrete trajectory instances. The first strip tracks a mobile task navigating QQ music, while the second shows a complex web search for a vegetarian lasagna recipe, with blue arrows marking every interaction step. Alright, Figure 3 lays out the 4-stage training pipeline that makes this performance possible. It starts on the left with the Qwen3VL base model, which undergoes a mid-training phase to inject domain-specific knowledge. Next, the pipeline splits into 3 parallel tracks during the offline RL stage, specializing in grounding, mobile, and web tasks respectively. The mobile and web branches then advance to an online RL phase, which allows the agent to learn from live interactions in dynamic environments. Finally, on the far right, a model merge strategy unifies these specialized experts back into the single UI-Venus-1.5 agent. Well, having seen the training pipeline in Figure 3, Table 1 now quantifies the resulting performance on grounding benchmarks. Grounding refers to the model's ability to precisely locate and identify interface elements, which is a prerequisite for accurate clicking. The table compares the new architecture against both general vision language models and specialized GUI agents. In the bottom rows, the UI-Venus-1.5 family demonstrates clear superiority across the board. The 30 billion parameter variant, for example, reaches 75% on Venus Bench GD and roughly 70% on ScreenSpot Pro, significantly outpacing competitors like MAI-UI. So, Table 1 covered static grounding. Now, Table 2 tests the models in dynamic environments using the Android World benchmark. The table splits candidates into 3 groups: general vision language models, specialized GUI agents, and the new Venus family. In the top section, general models like Qwen3VL struggle, scoring only around 54%. Moving to the middle section, specialized baselines like MAI-UI perform much better, reaching about 73%. But looking at the bottom rows, the UI-Venus 30 billion parameter model dominates with a 77.6% success rate. Notably, even the 8 billion parameter variant beats the strongest previous competitor, proving that smaller, well-trained models can punch above their weight. Alright, while the previous table showed the final destination, Table 7 maps the journey, breaking down how performance evolves through each training stage. Starting on the left with mid-training, we see the baselines. Then, moving to the offline RL columns, the red text highlights immediate improvements. For instance, the 8 billion parameter model gains almost 7 points on ScreenSpot Pro, proving that static reinforcement learning solidifies the basics. But the real leap happens in the online RL stage. Look at the Android World column for the 2 billion parameter model. It skyrockets by 14.5% because the agent learns from live interactions. Finally, the model merge columns on the far right show the trade-off. While there's a slight dip in grounding accuracy, the 30 billion parameter model actually hits its peak on Android World, successfully unifying these capabilities. To wrap up, UI-Venus 1.5 proves that integrating large-scale semantic pre-training with online reinforcement learning is crucial for mastering dynamic environments. By merging specialized capabilities into one cohesive system, it sets a strong precedent for future generalist agents that can reliably automate our daily digital tasks. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.